Hello guys, welcome back. Today in this video tutorial I will be taking a new proximity sensor, that is TMD2771. Now to have a better perspective regarding the sensor, let's visit the website, that is controleverything.com, and here we have to search for this particular sensor and let's see what we got else from that. And as you can see, it's an ambient light sensor with 16-bit proximity detection, and these are some of its more prominent features which you can see on my screen. You can also have the ability to purchase the sensor from this website from here. Furthermore, I will be interfacing the ambient light sensor and the proximity sensor TMD2771 with a BeagleBone Black and using a C code. To get the C code, let's go to resource tab, and here comes the C code sample as you can see on my screen. Now you can download the code as a zip file from this website. Also, you can have the code from github.com, and the repository there is Control Everything Community. Now what do we require is to have a look over the hardware connections we need to set up, and let's face it. In the hardware section, the first requirement which you can see on my screen is a BeagleBone Black. Now this here is an I2C Shield for the BeagleBone Black. This is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier for other I2C devices that to be connected with it. Now gently place this I2C shield over the BeagleBone Black and make a connection just like that. Now what do we require next is our proximity and ambient light sensor, that is TMD2771. Now this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and for the same reason to the I2C shield. The next thing we need is to power up the BeagleBone Black, and there are two things we require. First of all, this is a mini USB cable just like that, and gently insert it over this jack. The next thing we require is a 5-volt adapter, and gently insert it over the power jack here. Now we need an internet connection to set up, and there are two things we can use. First of all, an Ethernet cable or LAN cable just like that, and gently insert it over here, the Ethernet jack. The next thing you can use also is a wireless USB nano adapter in case if you don't have the first thing. So we are all done with the connections. Now what do we require is to have a look over the C code, and let's face it and interface that with the sensor and BeagleBone Black. Well, for the interfacing part, what do we require is to have a look over C code, and to locate the C code we have to log into github.com, and here we have to search for the repository, that is Control Everything Community, and get over it. And here the sensor is TMD2771, and this is here, it's ambient light and proximity sensor, and this is the C code. But before that, let's have a look over the instructions we need to fulfill the C code. As you can see, first of all, the thing you need is to set up the BeagleBone Black, and the steps are being provided on beaglebone.org. Please follow it, and after that you can download or git pull the code in BeagleBone Black, and then to compile the C code, this is the command, and to run the C code, this is the command. Please note it down. After that, get back to the C code. As you can see, it's a .c extension file, and let's proceed with the code explanation. You notice in the code that we have included some of the header files needed for the functioning of this code, and in the void main function we have some sets of functioning which you can see. We have, first of all, we have to create an I2C bus and check whether the bus is there or not, and after that we have to check for the I2C device and check for the address of the sensor, that is 0x39. Then for the writing section part, we are sending some commands which you can see, and I will explain it now. For the first thing, we have to select the proximity time register, which is 0x00, or with command register 0x A0, and we have to send the command to set power on proximity wait and ALS enabled, which is 0x0F, and the writing command is here. After that, we have to select ALS time register 0x01, or with command register, that is 0x A0, and we have to set the command for A time, that is 101 ms, it's 0xdb, and the writing command is here. Then we have to select proximity time register 0x02, or with command register 0xA0, and we have to set the command to select P time equal to 2.72 ms, maximum count 1023, and 0xFF is that, and the writing command is here. Then we have to select wait time register 0x03, or with command register 0xA0, and we have to send the command to select W time equal to 2.72 ms, 0xFF. and the writing command is here. After that, we have to select pulse count register 0x0A or with command register 0xA0, and we have to set the command for pulse count, that is 40x04, and its writing command is here. The last writing command, you can say it's to select the control register 0x0F or with command register 0xA0, and here we have to send the command to select 120 milliampere LED strength. Proximity uses channel 1 diode, P gain and A gain are 1x each, and it goes to 0x20, and the writing command is here as you can see. Then we have a delay of 1 second as you can say. Then we want to read the data back from the sensor, and you can see we are reading 6 bytes of the data from the register 0x14 or with command register 0xA0 as you can see here. It's the channel 0, channel 1 and proximity data, and the command is here as you can see. Then we have to check the data whether it is correct or not, and if it's correct, then the conversion of the data takes place here, which is according to the details, the formulas and the conditions provided in the data sheet for the sensor TMD2771. After so many things, we have to finally print the data output on the screen, which you can see as the ambient light luminance in lux and proximity of the device. So you can see the code is here. Now what do we require is to have a look over the working, the practicality of this C code along with the sensor and the BeagleBone black. Now let's have a look over the working section, and for that we have first of all to copy this entire code as you can see, and after that we have to look over the terminal for the BeagleBone black, and here we have to create a new file with .c extension which you are able to see on my screen. And after that we have to paste the entire code here, and let's see, after that the last part is to save it. Then for the compilation process, as you can see, this is the command which you have already seen in the instructions part, and the code has been compiled successfully. Now to build and run the command, the code, this is the command, and let's see what we got here. As we have the ambient light luminance in lux and the proximity of the device. As we are running the command, you can notice there is a very small change, which means there is no interference regarding the intensity of the light falling on the sensor or any object. But when I place some object over the sensor and run the command, you can see the change in ambient light luminance and the proximity of the device. So this is how the sensor works, but instead when I bring a light source near to the sensor and run the command, you can see the increase in ambient light luminance and there is a change in proximity of the device. As I bring the light source near to the sensor, you can sense the ambient light luminance increases a lot and proximity of the device also. So this is how the sensor works. Now let's have a look over the applications and the benefits of this sensor. The TMD2771 family of devices provides digital ambient light sensing ALS, a complete proximity detection system and digital interface logic in a single 8-pin package. The proximity detector includes a digital proximity sensor, LED driver and IR LED, which are trimmed to eliminate the need for end equipment calibration due to component variations. Excellent background light rejection allows the device to operate in environments from sunlight to dark rooms. These features make it very useful for applications like cell phone backlight dimming, cell phone touchscreen disable, notebook monitor security, automatic speakerphone enable, and a lot many. This sensor can be purchased from the website controleverything.com, and you can have the code from the source tab, and after that you can download the code as a zip file. You can also have the code from github.com, and the repository there is Control Everything Community. In the end, I would make it clear that for any further queries, you can reach us on controleverything.com, and to post your comments, you can post on the community page. For blogs and articles which are relevant to this sensor and the code and the video, you can go to instructables.com, and to subscribe more video tutorials just like this, you can have a look upon our YouTube channel. I hope you enjoyed this video, and thanks a lot for watching.